Hi, my name is Emily and my partner's name is Abby, and today we'll be talking about polynomial in behavior. When looking at polynomial in behavior, you're trying to see which directions your polynomial ends. If it ends up down, or if it ends down up, or down down. And in determining this, you're trying to find if your multiplication of highest degrees are odd, even, in your exponents, and negative, positive, in your coefficients. So to begin with, we're going to start with x to the fifth plus 4x and x plus 3. To start off, we're going to use our term of highest degree, which means the x with the highest exponent in each. In this case, that'd be x to the fifth and x because 5 is a higher exponent than 1. So you're going to put down x to the fifth and x. You're going to multiply these two. And now when multiplying exponents, you're actually going to add them. And x is actually x to the 1, so you're going to get x to the 6. And then you're going to multiply your coefficients. In this case, x is 1x, so when multiplying 1, you get 1. So your final answer is x to the 6th. First, you're going to look if your exponent is odd or even. In this case, 6 is even. And then you're going to see if your coefficient is negative or positive. And in this case, 1 is positive. And when it ends in even, that means that you have two options. It either goes up, up in the same direction or down, down in the same direction. They both are the same. And to determine that, you look at your positive or your negative. And if it's positive, it goes up. So you easily can decide that this polynomial ends up, up. Meaning as x approaches negative infinity, your y will approach positive infinity. And as x approaches positive infinity, your y will also approach positive infinity. So your polynomial could look something like this. Our next example is negative x cubed to 4x cubed plus 4x minus 6 and 4x in another parentheses. Again, we're going to start with our term of highest degree in each, that is negative x cubed. It's 4x cubed and 4x. And then we're going to multiply them together, starting with the exponents. Again, when multiplying exponents, you're actually adding them. So 3 plus 3 plus 1, because x is x to the 1, equals x to the 7th. And then you're going to multiply your coefficients. So in this case, negative 1, because negative x, 4 and 4. And then multiplying negative 1 and 4, you get negative 4 times 4 is negative 16. So you get negative 16x to the 7th. And to begin with, you look if your exponent is odd or even. 7 is odd. And then you look if your coefficient is negative or positive. Negative 16 is negative. Now, when it says odd, if it's odd, that means your y will end in opposite directions, unlike even. So you have two choices again, up, down, or down, up. To determine if it's up, down, or down, up, you're going to look at your negative or your positive. If it's negative, your second one will go down, and if it's positive, your second one will go up. In this case, it's negative, so it's up, down, meaning that as x approaches negative infinity, y will approach positive infinity, and as x approaches positive infinity, y will approach negative infinity, meaning your polynomial could look something like this.
In our next problem, we're going to be looking at 2x to the 5th times x to the 3rd times 7x plus 5. The first thing we have to do is find the term of highest degree, which we know is AXN. In order to find the term of highest degree, we have to multiply our coefficients, which in this case are 2 and 7. 2 times 7 equals 14. So we know that's the beginning of our ax to the n, so 14 is our a. In order to find our xn, we have to multiply our exponents, which in this case are x to the 5th, x to the 3rd, and x to the 1st. When multiplying exponents, you only add them. We learned that in our laws of exponents. So, in order to do that, we would get x to the 5th times x to the 3rd times x, which equals, since we know we have to actually add them, is 5 plus 3 plus 1, which equals 9. X to the 9th. When determining the end behavior for this problem, we can now see that our coefficient is positive and our exponent is odd. When an exponent is positive, it ends up, and when an exponent is odd, it ends the opposite way that it did before. So in this case, it would be down. If we looked at this function on a graph, it would look something like this. The end behavior would be as x approaches negative infinity, y approaches positive infinity. And the opposite of that, as x approaches positive infinity, y also approaches positive infinity. And that completes this first problem. For our next problem, we're going to be working with negative 5x squared times x plus 7 squared. This problem looks a little bit different because of this squared on the outside of the parentheses, which we're usually not used to seeing, but it really doesn't make that big of a difference. We are still going to find our term of highest degree the same way, AXN. So first we do our coefficients, which would be negative 5 and 1. So negative 5 times 1 equals negative 5. So we know that our A equals negative 5. Now, in order to find our exponent value, we still bring down our first x to the second, but instead of just bringing down an x to the first, we multiplied the x to the second out to the x to the first. So that would then make it multiplied by another x to the second, which we know is actually just adding the exponents, which would then make it x to the 4th. So we know that our xn equals x to the 4th. So then when we finally put it all together, we get negative 5x to the 4th as our term of highest degree. Now that we have found our term of highest degree, we can now determine the end behavior. Our exponent is even, and our coefficient is negative. We know that when our exponent is even, the arrows both go the same direction. And since we've determined it is negative, we know it goes down. So it's down and also down because it is even. If we put this equation on a graph, it would look something like this. We can now determine that as x approaches negative infinity, y approaches negative infinity. And as x approaches positive infinity, y approaches negative infinity, therefore creating the down-down effect. Now let's take a look at linear, cubic, and quadratic functions. Anything to the first power is linear, anything to the second power is quadratic, and anything to the third power is cubic. Quadratic can also be even, and cubic can also be odd. Let me show you how we would look at this in a problem. In this problem, we have 4 times x plus 2 squared times x minus 2 cubed times x minus 3. In order to determine our roots, we just set them equal to 0. For this first section, I just set x plus 2 equal to 0, subtracted 2 from both sides, and got x equals negative 2. Now I will do this for the rest of the problems. That then determined my roots to be negative 2, 2, and 3. Now that we have found our roots, we can determine if they are linear, quadratic, or cubic. Our negative 2 root would be quadratic since it has a 2. So our negative 2 is quadratic. Our positive 2 would be cubic because of the 3. And our positive 3 would be linear because there is an exponent of 1. Now that we have found our roots and their end behavior, now we find our term of highest degree, which we know is AXN. In order to find our term of highest degree, you multiply the coefficients and the exponents. In this case, our only coefficient is 4, which makes our A 4. And from here, we just add our exponents, which would be 2, 3, and 1, giving us 6. 4x to the 6th. Since our coefficient is positive and our exponent is even, the directions of our arrows both go the same way. And since it's positive, they both go up. Now let's take this to a graph. First, we place our roots on the graph. Negative 2, 2, and 3. A quadratic behavior always bounces. A cubic behavior always swivels through, and a linear behavior always goes directly through the point. Knowing these rules, we can then graph our line. Since we know our end behavior is up, up, we start our line at the up point. Now, we determined that our negative 2 was quadratic, therefore it bounces. Our 2 is cubic, so it just swivels through. And our 3 is linear, so it's just a straight line through. That is what our function looks like graphically. As x approaches negative infinity, y approaches positive infinity. As x approaches positive infinity, y also approaches positive infinity. Thanks for watching!